Hi there and welcome to another episode of TRX Bench. Yeah, today we have here an Yaesu FT1000. And this radio is not willing to receive, so you see I've already connected here the radio to the communication tester, and yeah, when we crank up here our AF gain, so maybe a little bit barely in the background, and we are feeding in with minus 43 dBm, which is really a strong signal, actually a signal of S9 plus 30 dB, and you see it behaves like it is a completely dead receiver. I've tested it already over all bands, and the radio is showing everywhere the same behavior. So yeah, there is definitely something serious inside our circuit, and therefore we have to crack it open and let's see what's going on here. Okay, and always the same question, where to start. And as we have no receive on all bands, so I believe it could be something here in the front end, and we have to make sure that the signal is going through, and therefore first, and here is our block diagram, and let me zoom in here that we see where we are. And well, important to us is of course here, I can enlarge it just a little bit more. So we have two antenna inputs. So this is our antenna unit, this is then here our low pass filter unit, but we see that this is a filter unit for transmit, because this is our PA unit, and therefore, you know, this is our transmitter low pass filter unit. So therefore I do not believe that we have a problem here. And the next, then after here, our antenna unit, low pass filter unit, is that we have an incoming signal on our RF unit. And well, RF unit, so there are a lot of steps where we need to go through, because we have here our RX, and I believe it is RX antenna switch. So it is what we can see here. Okay, and then we have our attenuators, 6 dB, 12 dB, and then we already got here to our filter package for receive. And yeah, let's go through this here, because I believe that there is a problem, and therefore let's change over here to yeah, RF unit. So let's look into our RF unit, and here it is. And what we see is of course what we have seen on our block diagram. So we have here our RF input, RX input, right? And what we can see here, so here we have our attenuators, which get switched in by you know, an relay, or better it get switched out, because if you see that it is going through and passing by here our attenuation elements. Right, and then we move forward, and we are getting here to a first interesting part, because we have here so it is a kind of protection diodes which we have here before we go any further, and finally gets here to, you know, the bandpass filters for our different bands. Okay, and that is where we should start. We have to follow our signals right from the input through our circuit here and see how far we get. Do we get through our bandpass filters? But as you can see here, of course, for any band we have here a dedicated bandpass filter, and if only a bandpass filter is faulty, then we would see the problem on one or maybe two bands, but we see the problem on all the bands, and therefore I believe there is a issue before here our bandpass section. Okay, so let's go down into the radio and let's see what we can do. Alright, and I've already opened here our RF, not opened the RF PCB, but I had to take off here our power amplifier unit, because the power amplifier is sitting above here our RF board, and this here of course is our fan for cooling down our PA unit. Right, so what we can see here, so this is our RF unit, and you see here this is a bandpass filter section, and of course we have here a lot of relays switching between all the different states, and yeah, what have we. And of course we have here our antenna unit, so that means you can see it here. We have two antenna inputs, and you can switch between antenna A and B, and here we have then the outgoing signal, and it will pass through here our low pass filter unit. Yeah, it is not only the PA unit, so we have here of course the PA unit for transmit, and we have our low pass filter section for transmit here on the PA unit, and then the signal will come down here to our RX board, and we should see down here, where is it? Down here we should see of course our signal, because that is a point where it goes into our unit. Well, and I thought that is an excellent job to use here our new restored signal tracer, our IT-12 from Heathkit, and you see it is already switched on, and let's see if we are able to follow our signal through the radio, and let's see if we can find our problem with a device, with a tool from the 50s or maybe early 60s. So let's see what or how we can use here our IT-12. Alright, and I've here my probe, and let me put here some gain, yeah, so we can hear it. It is working, and as I said, let's here step through our unit, and here of course is our input, and we can hear that of course we have a signal. which I hope you can hear it. So let me... Yeah. Okay, so there we have a signal, and of course if we pull this little corks, wrong side, of course this can't go. I just wanted to grab, let me go down here, I wanted to grab this one, because this is the one which is coming out our transmitter low pass filter board, and here we should see the signal, and we do. So very nice. So we know that our signal is down here at our RF board. I can't get here my coax connector back into the socket. Ah, come on. What is that? Okay, so now it is in, and now we have to pass through here our unit. But before we go ahead, that you can follow me, let's have a little look onto our schematic. Okay, and what we have already done, so we have here tested our input into our RF unit, and here at that corks we had our signal, no problem. And of course we could have a problem here in one of these relays, because now it's going through here all the relays, and for instance we could pick here our signal at L1085, and when we go over here, so this is here our socket where we test it, and we have here our L1055, so is it 55 or 1085? Sorry, our 1085, and we should read, we should be able to read our signal down there. Okay, so here's our board, and now let me see. Yeah, so we see here our 1085. Is it right? I believe 1085. It is down there, so you can see it here behind all our wiring. And yeah, let me go down there to this little coil, and let's see if we have a signal down there. And yes, we have. So now we know that the signal is passing through our relay, and we can go ahead. Okay, and let's go finally down here to our D1055, and then what is it, D1056 I believe. Let's see if we can better see it here on our plan, our board plan. And what we have here, yeah, so that is a better view. So we can see here our D1055, and we should be able to read our signal down there. And here we are back on the board, and there we have our 1055, so I hope you can read it down there on the board. Let's see what's going on with our signal. Loud and clear, no problem. Okay, so our signal is already there. Alright, so where have we tested? We have tested there, and we have our signal already here, which is good. But now we need to find our 1056, I believe, because of course we want to see is our signal here at our cathode, and of course our signal needs to pass through, okay, to go ahead, and therefore we watch out here for our 1056, which is, let me go over here. Alright, so here's our 1055, and we have seen that at our cathode we should find, and we should find our D1056. So that is a SMD diode here, and here of course again our cathode. So let's go down to that diode, and we check of course here at the input, and we have to check at, let me call it output. It is of course the anode, but our signal has to pass through. Okay, and again for orientation, here is our 1055, where we have already tested, and we have seen we have signal down there. So let me zoom in. Alright, so here it is fine, and there we have our 1056, and of course we should find our signal here at the cathode, and that is exactly what we want to do right now. So let me go down. Alright, and you see no problem at all, so we have our signal down there. And now of course signal has to pass through. Let's test what we have here. No signal. And of course the signal should be in the same way available like we have it here. It should here as well, but you see it is not. So that is the first indication that something must be wrong here, but it must not subsequently the diode itself, so it could be our biasing voltage, and of course that is what we have to test first. And I mean, you all may know that a signal can't pass through a diode if the diode is not biased. So we definitely need the diode biased, and therefore in its working point. And if the diode is in its working point, then a signal can pass through. Otherwise the signal wouldn't get through, so no way. And therefore of course we have to check if we have a bias voltage, and that is of course DC, and of course the bias have to be at the anode, right? And then if there is a voltage, then we test at cathode as well, because we should see approximately the same voltage except for our voltage drop, which we have at the diode, which is depending on the diode between 0.3 up to 0.8 volt. So as I said, depending on the diode. Yeah, therefore let's test what we have. Okay, and so you should be able to see my multimeter, and I go down to the anode. Let's see, and fine. So we have 7.1 volt at the anode, so that means the bias voltage is present. So let's see what we can read at our cathode. And oops, cathode, nothing. And that is, as I said, not possible, because if the diode would be fine, of course we would see here the drop, the voltage drop across the diode. So in our case it would mean once again here 7.5 come on, 7.1. so let's see, I don't know, 6.5 or whatever. So that is what we should see here on the other side of the diode. But there is nothing. That means that all the voltage is dropping here at our diode, and that means that this diode must be open. So this diode is dead, and that means we have to take this diode out, and yeah, of course we have to replace it with a new diode. Okay, so I try to grab the diode here with my tweezer down there, but again it is always the same problem. I can't do it here around the camera, so please forgive me, but I have to do it off camera. But basically I just go down, grab it and take it off, so that is really no big deal. Alright, and we need a new SV271, and I have some on stock, so let's go ahead here. Okay, so our new diode is in down there, and yeah, ready for testing so far. Let me set here my generator to -73 dBm. Hey, come on, what's going on? Okay, so it is set to -73 now. Okay, everything is connected. Wonderful. Let's test what's going on here. Wow! Woo! Wow! That is awesome! Let me see here. Let's go back to 300 millivolt and let me check here. Awesome! That is awesome! And we have a nice and clean sine. We have a very good synod, and our distortion is just fine. That is absolutely fine. And let's see here. Yeah, I don't switch off the camera, so sorry for the work here, for the camera work, but then you can hear, where's the reflection coming from? I don't know. But what I just wanted to show you is that our S meter is showing S9 with -73, and again that is absolutely awesome. Radio is back working, so it was this little protection diode, and after replacing, it's working. Alright, so, and of course I've tested here our receive on all the different bands, and everything is just fine. I'm back now on SSB testing with our signal tracer, meant to have it in AM, right? Now it is back in SSB, because that is of course important, the important mode. And yeah, the signal is excellent, so we have a synod of 40 dB which is awesome, and we have an absolutely clean signal, and so therefore everything is just fine. Okay, maybe our last question is why are these diodes dying? So as I said, it is a kind of protection diode, of course, not only, but it is also doing this function. And well, this diode very often dies because of a very high input power or a high input voltage, whatever you want to call it, maybe a surge or whatever. So therefore something has happened when this radio was connected to the antenna, and well, therefore that is what most likely happened to the radio. But anyways, it's back working and it can go back to the old man. Okay, so that's it for today. Hope you enjoyed it a little bit, especially trying to find our fault with our old signal tracer, and you've seen it worked. So this gear is awesome as well. Okay, thanks for watching. Hope you enjoyed it a little bit, and if so, please give me a big thumb up. Bye bye, and catch you next time.